Hello everyone, welcome to Incredible Study. Today in this video we are going to discuss our next topic related to this chemical bonding. So without getting delay, let's get started. Here now we discuss about chemical bond. This is our topic. So first of all we have to be familiar with the term bond. What is bond? Bond means the force of attraction. It means the attractive force is simply called as bond. And we are familiar to the fact that not all the elements are stable. It means not all the elements can stable and have free state. Except noble gas, all the atoms of other element have tendency to combine with other element or the same type of atoms to form the cluster or aggregate atoms with definite composition. It means other elements have tendency that can combine with other element to be stable, to form the stable molecule or ion. So the force existing between the two atoms is simply called as chemical bond. So here we write definition. The force of attraction existing between the atoms which form between the atoms which form aggregate atoms, aggregate or cluster atom. Here cluster atom means the unstable atoms are bound together to be stable. They are called cluster atoms. Each called chemical bond. And there are two types of chemical bond. Is categorized into two types of bond. They are strong bond and weak bond. Here we categorized bond. Chemical bond. Chemical bond is categorized into two parts. That is, they are strong bond and weak bond. And the strong bond is further categorized into three types of bond. They are, here we categorized this strong bond. They are electrovalent bond, second number covalent bond, third number coordinate covalent bond. Coordinate covalent bond. So these all are strong bonds. These all bonds are strong bond. Electrovalent bond, covalent bond, coordinate covalent bond. So here 1 number, 2 number bond, 3 number, right? And there are two types of weak bond. Here we write. So first one is hydrogen bond. and here van der Waals force. Van der Waals force. Here weak bond is categorized into two types of bond. First one is hydrogen bond and second one is van der Waals force. Besides these all bonds, there are one more bond, that is metallic bond, which exists between metals. So metallic bond falls under strong bond. It is a strong type of bond. So here we write under metallic bond, that is 4 number metallic bond. Here this is also a strong bond, and here we replace 4 by 5 and 5 by 6. So under this chemical bond topic we are going to discuss this all types of bond. So at first we discuss about electrovalent bond in detail. Here under our topic, that is electrovalent bond, we discuss this all topics. First one Lewis electron dot symbol, second one electrovalency, third one electrovalent bond, fourth one electrovalent compound. Here our first topic is Lewis electron dot symbol. So here at first we deal our first topic Lewis electron dot symbol. So G.N. Lewis, it means he was a American chemist. He developed one concept or introduced one notation, simple notation to represent the valence electron of element. And according to this he uses notation that is called Lewis symbol or electron dot symbol or cross symbol. And according to this notation, electron dot notation, the symbol of element represent nucleus as well as other electrons in shell, and cross symbol or dot symbol represents other valence electrons. It means here according to this notation what happens, here we take one element, this is the symbol for sodium, and this symbol represents nucleus of sodium as well as other electrons in it, and either this dot or cross we can write. If we write cross, then we have to rub dot. So here we write cross. This cross represent the valence electron of sodium metal. It means the valence electron of sodium is 1. And for chlorine we take this dot or cross we can take. Here we take dot. So this dot represent the valence electron of chlorine, and this symbol represents the nucleus of chlorine as well as other electrons present in it. So this is the concept of electron dot symbol. This is the notation for electron dot. We use electron dot method to show the formation of electrovalent bond. Now we move to our next topic, that is electrovalency. Electrovalency is such a valency in which electrons transfer from metal to non-metal, that is electropositive elements to electronegative elements. Third number, here we write definition for electrovalency. So here electrovalency, we write electrovalency. This is, and here we write definition. Electrovalency is such a valency in which electrons transfer from metal to non-metal, metal to non-metals, or electropositive element, electropositive element to electronegative element. Electronegative elements. Here it means we take example here. We take sodium. This is sodium metal, and we know here the valency of, we know this is electropositive elements, and this is electronegative element, that is chlorine. When the electron transfer from here to here, then what happens? Here it gains plus sign and it gains minus sign. So we can determine the electrovalency of sodium and chlorine here. So since the only one electron get transferred from sodium to chlorine, that is electropositive element to electronegative element, so the electrovalency of this sodium is 1, not only 1, plus 1. We have to determine sign here. We have to place sign so that we can know easily that it is a metal, electropositive element. And here the electrovalency of chlorine is minus 1. Here this is the concept of electrovalency. Now we go to our third topic, that is electrovalent bond. Here our third topic is electrovalent bond. The bond which is formed due to the transfer of electron from metal to non-metal or electropositive elements to electronegative elements is called electrovalent bond. So here we write definition and we take example to understand clearly. The bond formed due to, this is the definition of electrovalent bond, that is the bond formed due to the transfer of electron from metal to non-metal or from electropositive element to electronegative element is called electrovalent bond. So here we take one example. This NaCl, this is a electrovalent compound because this compound is formed by the electrovalent bond. It means electrovalent bond is present in it. So here we use electron dot method. This is electron dot structure. We are going to draw the electron dot structure to show the formation of electrovalent bond in NaCl. So here we know the valence electron of sodium is 1. So here we denote this 1 here by using dot, and in chlorine we know how much. We write electronic configuration, right? 1s2, 2s2, 2p6, 3s2, 3p5. So here we know there are 7 valence electron. In here you can see this is outermost shell, and the electron present in chlorine is 2, that is 2 plus 5, 7. So here we represent this 7 by cross symbol. This is 7. Chlorine has 7 valence electron, and here this electron get transferred to this chlorine. Therefore here, since sodium loses 1 electron, so sodium forms its cation, that is Na plus. This is the cation of sodium, and since the here chlorine gains electron, therefore chlorine forms anion. This is the anion of chlorine, anion of chlorine, and this is cation of chlorine, sorry, cation of sodium. This is the cation of sodium and anion of chlorine. So here this is NaCl is formed by the transfer of electron. You can see this is metal, this is non-metal. So the electron get transferred to this chlorine and compound is formed named NaCl. We know it is also called table salt, common name, sodium chloride. So this is the NaCl is the electrovalent compound, and the bond formation we show using this. Here we show bond formation like this. Since sodium metal loses electron and chlorine metal gains electron, so we use this. This is the proper way to show electrovalent bond here. And now we move to electrovalent compounds. We see some electrovalent compound using Lewis dot structure. We also draw the Lewis dot structure. We have studied about this electrovalency and electrovalent bond, and here our topic is electrovalent compounds. So the compounds which are formed due to electrovalency and electrovalent bond is called electrovalent compound. We can use these two terms to define electrovalent compound. Here I am going to write the definition of electrovalent compound. The compound we write here example, that is first one is NaCl, second one is MgO, here CaCl2. These are some examples of electrovalent compounds. Here the formation of electrovalent bond is shown using the electron dot method or electron dot structure. For MgO we write here, for MgO, magnesium oxide. So here we write electronic configuration for Mg. Its atomic number is 12. So here 1s2, 2s2, 2p6, 3s2. This is the electronic configuration of magnesium. And oxygen we write 1s2, 2s2, 2p4, because the atomic number of oxygen is 8. And now we draw the Lewis dot structure to show the formation of electrovalent bond in the compound MgO. Here we write Mg and O. Now we have to write the valence electron. It means here 4 plus 2 in oxygen. So 6, 1, 2, 3, 4, 5 and 6. And here Mg has 2 valence electron. You can see this is the outermost shell, and the electron present in the outermost shell is called valence electron. So here we write 2. You can see this is. Now we are going to show the formation of this bond. Either you can do like this, or you can use atmospheric symbol. It means you can directly use 1. Here you can do like this, just complete transfer of this 2 electron of Mg to oxygen. Therefore here in Mg it forms cation, here 2 plus sign, because there are 2 valence electron which is transferred to other element, that is oxygen. And here oxygen gains minus 2. So here we write MgO, plus plus minus minus. This is the formation of bond. This is electrovalent bond. We can show electrovalent bond like this. And now we take CaCl2 for CaCl2, and we write electronic configuration for calcium 1s2, 2s2, 2p6, 3s2, 3p6, and here 4s2, 6, 10 and 10, 20. And now for Cl, chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. The valence electron of chlorine is 7 and the valence electron of this calcium is 2. So here we write calcium. You can see Cl atom is, there are 2 chlorine atom. So we write one chlorine this side and another chlorine this side. And now we write this valence electron in calcium. 2 valence electron, we write 2 dot, and here 7. 1 2 3 4 5 6 7. Similarly 1 2 3 4 5 6 and 7. So here this electron get transferred to chlorine and this electron get transferred to this chlorine. Here calcium loses its 2 electron, so here calcium gets 2 positive charge, and here one chlorine atom gains 1 electron, so here chlorine gains 1 negative charge, and we write this compound as this Ca plus plus Cl2 minus. Because there is 2 chlorine atom, so we use only one minus sign to represent 2 chlorine atom, the sign of 2 chlorine atom. So here in this way we have completed our electrovalent compounds. We have understood about electrovalent compounds and these all basic terms. Now we understand the properties of electrovalent compounds. Here now we discuss the properties of electrovalent compound. Electrovalent compounds are also known as ionic compound. So here first number, physical state. Ionic compounds usually exist in the form of crystalline solid. They exist in the form of crystalline solid, in the form of crystal. It means here we all know the electrovalent compounds or ionic compounds are formed by the transfer of electron from metal to non-metal. It means here positive and negative charges exist, and we know positive and negative unlike charges attract each other, so the attractive force exists over here between this metal and non-metal, so they are more stronger than other forces. Therefore here electrovalent bond is more stronger than other bond. Therefore they come closer and form the pattern like this: Na plus Cl minus Na plus Cl minus, here Cl minus Na plus Cl minus Na plus, here Na plus Cl minus Na plus Cl minus. It means one cation is surrounded by 6 anions. Here you can see this sodium is surrounded by 6 chlorine. Here one is this side, one this side, one is this side, another is this side, and 2 are like this at the front and back. It is in 3D form. Suppose this is a sodium, then this side 1, this side 2, this side at top 3, here this 3, in the bottom 4, and here one front 5 and one back one 6. So this one cation is surrounded by 6 anions here, and they form the pattern, and this they form the solid. This pattern is the cause of solid, so they exist in crystalline solid. Second number, they have high melting and boiling point. Since the stronger electrovalent, it means the stronger attractive force exists between them, therefore high melting point, they have high melting and boiling point, so the high energy is required to break the bond, so they have high melting and boiling point. Third number, they are soluble in water. Electrovalent compounds are soluble in water. Fourth number, they do not conduct electricity in its original or solid state, but they do this in its aqueous state. It means in the solid state they do not conduct electricity. We take example of salt, we take example of NaCl, that is sodium chloride. If we take it and we supply electricity, then this salt cannot conduct electricity. It means it unable to conduct electricity in its solid state or original state. But when we use the same salt as an aqueous solution, when we take water in the beaker and we put some salts inside it and then we conduct the electricity through this, then they conduct electricity. It means They do not conduct electricity in its aqueous state, in its original or solid state, but they conduct electricity in its aqueous state or aqueous solution. 5 number, they are hard and brittle in nature. They are hard, since they are crystal, they are hard and brittle in nature. Here they are arranged, we find like this: Na plus Cl minus, Na plus Cl minus, Na plus Cl minus. Here Cl minus, Na plus, this is arrangement, and here Cl minus, Na plus, like this. When the crystal of this electrovalent compound is hammered, then what happens? There is change in pattern. The pattern will be like this when we hammer the compound crystal. Na plus, it moves one step. It means it moves one step here. So here Na plus Cl minus, Na plus Cl minus. This is second one, and here first layer just moved one step this side. So here what happens? Na plus Cl minus, Na plus Cl minus, and here we write Cl minus because this is second layer, and in second layer it starts from Cl minus, and when it is hammered, then first layer move this side one step this side, and here you can see the same charge comes together. Here the same charge come together. So you all know same charge repel, like repel. So here this like charges repel each other and break down. So they break down. In this way crystal breaks. Therefore they are hard and brittle in nature. 6 number, cations and anions are arranged alternately. The same thing. Cations and anions are arranged alternately. It means first cation and then anion. First cation and next anion, and then after anion cation will be, and after cation anion. It means they arrange alternately. So we have understood about electrovalent bond in detail. We have also dealt the topic, Lewis electron dot symbol, electrovalency, electrovalent bond, electrovalent compounds and their properties. And one more thing here is ionic bond is non-directional. Here it means ionic bond is non-directional. It means ionic bond attracts all sides. When we take here Na and we take like this, Na valence electron of this sodium is 1, and here when we put chlorine this side, 1 2 3 4 5 6 and 7, then this anion, this electron transfer to this chlorine from this side also, from this side also. And when we put this chlorine this side, just here I am going to replace sodium. So here when this chlorine is put up, then this also attracts. It means sodium attracts this chlorine. Electron get transferred. Therefore they are non-directional. Ionic bond is non-directional. We can form ionic bond can be formed by any direction. There is no frequent, it means there is no definite direction for the formation of ionic compound or ionic bond. So here in this way we have completed all the necessary topics under electrovalent bond, and in the next part of this video we will deal about another bond, that is covalent bond. So for this video only this much, and I will catch up in the next part.